Okay, so I'll share my screen quickly so we can get the presentation started. So, is my screen visible? Just
Yes, it's
let me
visible,
know when you
Abdul.
can see. Cool. And I'm clear, right? My audio and everything is good.
Yes, it's perfect.
Cool. Awesome. So, I don't know how many of you sort of know about the community challenge and building and all of that, but I'll give you a quick overview as to why we are doing this and what is the point of all of this. So, community challenge is actually so community challenge is sort of a contest, a global contest by Facebook, and they sort of have it every year in some form or the other. So let's focusing on this year. The goal is to basically, in a nutshell, just write documentation for open source technologies, right? So we have sessions lined up that will take you through more in-depth details about community challenge. But one of the open source technologies that they sort of have given in their list that participants can write documentation on is Pytorch. So I'll be sort of taking you through. I don't know how many of you have used Pytorch, how familiar you are with it, but this one is sort of for beginners because to be very honest with you, even I don't use Pytorch that much. I know about it, sort of a bird's eye view of it, and what I see is you can take this as an opportunity to just write documentation, but sort of also get to know Pytorch a little bit and understand it. So if you're starting out, if you're a beginner, it can be really difficult to figure out, where do I start? Where do I enter? Because these things are huge. If you take any ML thing or any deep learning library, the very first thing you want to know is how do I get started with it, right? So this will sort of, the aim for this is to help you at least know where to begin. And then once you begin, you start gathering pace and you can then figure out which area you want to hit in. So that is the entire point of this session. I will not be taking you through the in-depth implementation of Pytorch, or we won't be writing any code as such. But what I'll be telling you is that if you are going to be writing a document which will serve as a manual for other beginners to get started with Pytorch, what can you write about and what possible points can you hit? Now you may have your own additional ideas in this, which is perfectly good, and that is what we want. But this is just a sort of serve as a guide, as I said. So that's the entire point. So it's called documenting Pytorch for beginners. So before we begin, sort of quick info on the DevC Community Challenge. So how do you go about actually, what exactly do you have to submit to the contest? And what kind of categories are there? I'll tell you a little bit of that. Of course, this has been covered by Yash also, I think, in the previous session, but I'll just quickly summarize it up for you in case you missed it yesterday, or in case some points weren't clear to you. So there are two categories that you can write tutorials on. There's a beginner, and then there's an intermediate to expert tutorial. Now, the Pytorch thing that we are doing today mostly hits upon the beginner tutorial category. But if you have a good hands-on with this technology, you can sort of pick the intermediate to expert tutorial too. So of course, the audiences for both of these is in the name, right? Beginners is mostly targeted towards beginner audiences, and the latter is targeted towards intermediate and expert audiences. As to what serves as beginner content and what serves as intermediate to expert content is something that I'll leave to your better judgment. So now, what do you need to submit based on the manual that has been sent by the Facebook people? Is your material, your tutorial will be on GitHub on your repository. So you have a 4,000 words limit. You can't cross that. So you'll have some kind of written material. In addition to that, most probably your written material will be doing something like, for example, if you have, let's pick a very simple example. If you write a simple hello world code, there is a very high chance that you have gone through some website, some tutorial somewhere that has told you how to write the hello world code, right? So that tutorial had some written content. It had a bit of code somewhere, and the entire structure. So that is your written material, which will be 4,000 words, and it will be on GitHub. In addition to that, you will have you may have images, you may have code snippets. Now, if you have code snippets, that software, that sample thing should be on GitHub. Okay. Any code that you have used, that should be on GitHub. A link of that has to be put. So it's basically it's an open source technologies, right? So everything has to follow the open source guidelines, and they're using GitHub as the main thing for hosting all your stuff. Why do I keep forgetting what it's called? Okay. In addition to that, there's also a need of a video, a walkthrough video of your tutorial. So basically, your tutorial may have what you've written will be a large document, right? Lots of images, lots of stuff, lots of sections. You need to have a walkthrough video that sort of tells what each section of document does. Okay, so that should be 2 minutes long and can be hosted on any of these platforms, YouTube, Vimeo, or Youku. Not sure what Youku, I've never used it, but YouTube and Vimeo you guys may be familiar with. In addition to that, you need to have the MIT license in your GitHub repo and across all your GitHub repos. And if you feel like you want to really have a more comprehensive video tutorial, right? There's also an option for that. You can have a maximum 30 minutes video, a comprehensive video tutorial where you can talk about whatever it is that you are covering in your tutorial. This is what you sort of need to submit. If you have more questions, we can take them towards the end of the thing, or you can simply drop it in the chat box and we'll be happy to address it. Questions pertaining to Community Challenge. If you have questions pertaining to Pytorch, we can take them take them when I take you through the Pytorch content, and you can interrupt me in between. That's no issue. So these are the sort of things that you need to do. The deadlines and all, I sort of haven't added a slide for that. When's the deadline for submission and what are the prizes? But the first prizes, if you sum them up, they amount to I think $133,000. So like that is a lot of money, and that is a very big amount of prize money. Of course, it's a global contest, so the competition is going to be tough, but the prize money is also that high. It's like 133,000. Like the first time I heard the first prizes amount to that much, I couldn't believe it. It was unbelievable. But yeah, it's true. That is reality. Okay. So let's sort of move on. Just a minute. Okay. All right. So now, moving on to the main context of the talk. So this talk won't be very long as such. It will sort of be a lightning talk. It'll take like 10-15 minutes at max. But I can tell you what can you document in Pytorch. Before we begin, I'll tell you a bit about what Pytorch is. So essentially, Pytorch is a deep learning. It's basically built for developing deep learning solutions. Okay. Now, one of the main confusions that people have is what is machine learning and what is deep learning. So if you have been dabbling even a bit in any of AI technologies, okay. So think of AI as a superset of everything. Okay. Now inside AI you have machine learning, and inside machine learning, as a subset to machine learning, you have deep learning. Deep learning is essentially a technique of machine learning. It is a technique that you can use to make your machine learn. Pytorch is for developing deep learning solutions. That is, in fact, that is their main agenda. That is why they made it. It was built on something called as Torch, okay, which was an existing framework, existing stuff already there. It was built on a programming language called Lua. Torch was built on a programming language called Lua. A group of researchers took Torch, added the capability of Python to it. Python is an imperative language, meaning every statement has its own meaning in a sense. And that is how the name Pytorch came in. Now let's come back to a little bit towards the AI aspect of it. You have machine learning. Machine learning, as the word suggests, is essentially making a machine learn. if some data, as human beings, we can see pattern in stuff, right? We can see a pattern in things. For example, when we were in school, right? And for example, if suppose there was an easy subject and everyone was scoring high in it, you would see the pattern. You would be like, hey, you know what? This subject, everyone scores high in this every year, every class, every student scores really high. That's a pattern, right? But then now let's consider 1 million students or 1 billion students. Now it's very difficult for a brain to comprehend all of that, right? To find patterns in that data. So essentially, machine learning does this for us. It finds patterns in huge amount of data. Now, when you're finding patterns, right, you can do a lot of things. You can either using these patterns, you can either recommend things to people. You know, you can really interact more closely with the users this way. You can get more stuff done. You can get more insights from the data. So like for example, if I'm into AI, right, and I want to take decisions based on data, I can build a decision tree, right? Or maybe I'll feel like I can do some clustering. Okay. Now these are all techniques in machine learning. Similarly, you have something called as deep learning. What is deep learning exactly? Deep learning tries to emulate the behavior of the human brain. Okay. The human brain works on neurons. Neurons are interconnected to each other, lots and lots of neurons. They're interconnected to each other. They all fire signals, and that is how we get our conscience, our capability to think and reason, our ability to think and reason. Deep learning tries to have neurons. Okay, each of these neurons are connected to other neurons, and all your data is fired through these neurons, and these neurons are sort of modified in a way. I won't say modified, but calibrated in a way that they can achieve a good output for you. Okay, it's like basically telling the machine to think like a human brain. Now these neurons are interconnected. I think those of you who are familiar with the term know what I'm talking about. These things are called neural networks. Okay, neural networks. Neural networks are basically neurons arranged in layers. You basically have a sort of an you have a middle layer, and you have an input layer and an output layer. Okay. Now you can have multiple layers depending on how complex your neural network is. So that is what these neurons do. That is what these neurons do, and that's what neural network does. I won't go more into depth of neural networks. All you have to know is there's a neuron. There are edges that connect every neuron to each other. Every edge has a weight. Every neuron has something called as an activation function, which is what activates the neuron. And you have lots and lots of different types of neural networks. Deep learning uses neural networks, which is why it's called deep. You have lots of layers of neurons arranged on top of one another, so it becomes deep. And because they sort of learn like humans through neurons, you call it deep learning. So that is what Pytorch is all about. Scikit is another popular thing available in Python, popular library available in Python that has lots of different methods that you can use. For example, if you want to do clustering, you have the k-means clustering available. You want to have a knife-based classifier. You have that available. You have everything available in Scikit. But Pytorch primarily focuses on the deep learning aspect. So you can do like a versus Scikit versus Pytorch. So Pytorch will focus more on a deep learning aspect. Scikit is more on general ML techniques as such. So that is the thing. So if you're going to be documenting Pytorch, you need to have some context on what it is. That was the point of telling you all of that. I didn't put it on slide because I didn't know how much to put or how little to put, so I'm just dictating it out to you right now. So yeah, we can have questions later on. Let's just quickly go into Pytorch. Okay, so let's look at the very first point that I can do. So yes, the way I suggested this, and in fact it's a very valid point, is if you're going to be documenting Pytorch, the very first thing that people want to know is how can I actually document, how can I actually install Pytorch, right? It's a bit of a struggle there. I think Yash can also tell you a bit about it maybe after the session. Is that it's a little difficult, especially for beginners. You know, if I'm coming in as a beginner, and let's just assume that I don't know anything about machine learning, or I don't know anything about AI and things. I just want to get started. And fortunately or unfortunately, I jump upon Pytorch. I come upon Pytorch, and I decide to learn Pytorch. Um, Usually, you start with more basic one. Let's say you stumble onto Pytorch as the first thing, and all of a sudden, the very first problem you have is, okay, I can write code. I understand Pytorch at a conceptual level, but how on earth do I get it to run? How do I install it? Right? So a lot of documentation online, and in fact, even the Pytorch website has a lot of configuration options. Okay, they ask you which version do you want? Do you want CUDA? Do you want this? Do you want that? And then they ask you these questions, and then they give you the command. Now this is fine for habituated people or people who are into it. This is in fact very convenient. But for beginners who are starting out, it's a little complex, a little intimidating. It's like the first time you went to Subway, right? And they were like, which bread do you want? I said, I want bread. I'm not used to being asked which bread. And they're like, there's Italian, there's this, there's multigrain, and there's this. And I'm like, okay, this is very intimidating. And on top of that, they ask you what type of sauce you want. And the only sauce I know at that point of time when I first went was called ketchup. And I used to call it tomato sauce. So you get the point. In fact, I took one of my friends who had in fact never been to Subway for the very first time a couple of like before the lockdown happened, a couple of months before the lockdown happened. And I could actually see how intimidating it was, and I remember that it does get intimidating for beginners. We get used to it after a while, but the first time you do it, it's really intimidating. So that is the problem with Pytorch too, is that installation is not very straightforward. You may need to set up an environment. You may have to set up an Anaconda environment. Some people are not comfortable with Linux. They use Windows, and Windows tends to have its own direction and own track in which it takes things. So it becomes even more difficult there. And it's not like you have like very straightforward tutorials available. There may be straightforward tutorials available, but they are not indexed on top by the Google search engine. So it becomes difficult to even stumble upon them. So if I want to be writing about Pytorch, and you are one of those people who's habituated to all of this stuff, how about you think back to a time when you were getting started with something very difficult, when you were getting started with something really complex in computer science, and you found it really difficult to get simply installed. And you can write a documentation that focuses on these aspects. Think of it as a question is, how would you explain some complex concept to a 10-year-old child? Okay, that way. But don't take the white hat junior way, lame joke, but yeah. But think of it that way and try to write document there. So Windows, Linux, and Mac are three OS that Pytorch is available on. You can pick either one or whatever you want. If you have a Macintosh, you can pick that too, or you can just simply stick to Windows or Linux. And you can structure a document in a way that shows how to really install Pytorch. I'll tell you what the document should hit, but this is one possible documentation point that I believe you can hit. And thank you, Yash, for suggesting it. It's a very genuine point. Okay. Second point. Ecosystems. What do I mean when I say ecosystems in Pytorch? So Pytorch offers a lot of different things for you, a lot of different tools and libraries along with, you might have some kind of visualization tool that helps you build all kinds of graphs using whatever data is coming out of your learning process. Or you may have some kind of say some kind of optimizer or some kind of a speeding up utility. What that will do is it will just speed up your learning process, or it may use some kind of optimization technique to help you. So these are all pluggable tools and libraries, right? Think of it like if you're using Chrome, you have extensions, right? So extensions help you just, they augment the process that they augment your web surfing experience. For example, I use one extension called HTTPS everywhere. So what it does is it attempts to make an HTTPS connection to every website I visit, which is a secure socket connection over the HTTP protocol. So I mean, it just augments my web surfing experience. So that is what these ecosystems are in Pytorch. You can plug them into your code in Pytorch and you can do it. You have lots of ecosystems. Okay, I'll sort of take you through all of these. I have the hyperlink in the presentation. I'll take you all of that in like 5 minutes. But you can also pick one interesting ecosystem. Yeah, there are lots of them. You can also keep scrolling through them, and you'll have to pick one that you understand and you feel you can really do. You can build something using it, and you can document that process along with an explanation. You can have images, you can have video, you have options for 2 videos, you can have that, or you can sort of even just write things, right? So this is one documentation point that you can head as ecosystems in Python, which is an interesting thing to explore. Of course, but to explore an ecosystem, you need to first be familiar with Pytorch. So this would fall, I think, more into the intermediate category if you're writing a tutorial on this, and it can be a little bit challenging too. So this is another point. Moving on to the next one, which is also my one of my favorites. Pytorch for mobile. Yeah. So let me tell you of a short story. A long time ago, when the world was normal and I was in college, we went for a hackathon, and we were supposed to build and we were simple people then. We didn't know much about machine learning and artificial intelligence as such. In fact, to us, our team of 4 people, in fact, Ankush was one of the members of that team, Ankush Pathak. He also takes a lot of sessions with FC. So we were told to build a mobile app that could identify plants, okay, based on pictures. Now, to us, at that point of time, this was in 2016, okay. At that point of time, it was machine learning and AI was something that was very far for us. Like, we just knew what it was, but we didn't really think like we could do it. Think of it like the moon. You see it every day. Some people have been there, but for you, it is just something that you don't really think you can reach. So that is how it was for us. We just used to feel like, that I don't really think there's something for me. Okay. Of course, that changed a couple of months later, but that is how it was at that point of time for us. Machine learning and all of these were just 2 heavy terms. But then we went to the hackathon and we used simple image processing techniques, very common image processing techniques, to identify what kind of a plant it is from the photo. And the judges came to us for the first round of judging, and they were like, you know what? Okay, what you guys have done is sensible, but this isn't what we're looking for. We're looking for a machine learning approach to this. This was a 48-hour hackathon. A 36-hour hackathon, not a 40, 36-hour hackathon. It was actually the first edition of the Smart India hackathon. So it was 36-hour hackathon, and they were like, we want a machine learning solution for this. And this was a mobile app. And for people and for us, where we had barely touched upon machine learning on a desktop system, they were asking us to do something on a mobile that we had not even done on a proper computer, right? At that point of time, you didn't have very powerful phones. Okay, like there were powerful phones, of course, but they were really expensive, and like none of us had that. And like even the solution we had was barely working using basic image processing stuff, because we were going pixel by pixel. So that was barely working on the Android phone. And they told us to use some kind of ML for this. That is the first time we didn't win that. Obviously, the winning team had an ML solution on an Android. And that sort of served as a turning point for all of us, because then we realized that ML is something that we can truly learn about, and it hurt us so much that we actually learned a lot about ML after that. And at that point of time, it was very difficult to have any kind of ML framework on a mobile. Okay, TensorFlow had just come in, and TensorFlow had one of their beta versions available for mobile use. Now we didn't know anything about that, and we were like 6 hours into the hackathon. We couldn't learn how to deploy an ML model into a mobile phone at that point of time. because we didn't even know how to do it properly on a laptop. Okay, so it was sort of a very difficult task. We tried our best, but it didn't work out. So TensorFlow somehow had this thing where you could deploy a model on the phone and you could do it. That is when I first stumbled upon this concept, because machine learning takes a lot of data. The training process takes a lot of data. Okay, even my laptop can barely handle it. It pushes the machine to a maximum. Okay, uh, so Pytorch for mobile actually gives you the ability to execute your machine learning solutions on iOS or Android mobile phones. Okay, that is a very powerful thing and a very necessary thing if you're building a truly intuitive application. If you're building an application that has AI at the center of it, okay, usually the solution would be to have a server that will have your model deployed, and your machine, your edge computing device, your mobile will communicate with that server, and the server will do all the data crunching for you and give you back the result. But that brings in dependency of network, that brings in latency, and that brings in performance issues. Okay, because you're communicating over a network. So every limitation of network communication comes into this picture. Okay, which is sometimes you may not want it. What if all of a sudden you have an unstable network connection? Okay, especially in remote areas. Or Pytorch for mobile is one such thing that allows you to deploy a solution onto the mobile. Even I have not explored a lot on this. In fact, I know nothing about this. Just whatever Pytorch documentation says. In code-wise, I know nothing about this as to how they're doing it. But I'm definitely interested to know more about it. Because it's something that's really cool, to be very honest with you. So it is still a beta stage, but you guys could possibly build something, folks, all of you. You could have like a simple image classifier, or it's just anything, any simple thing that has some kind of ML at its core, and it is running on a mobile computing device. I'm not sure how much of processing they leave to the server and how much processing they do on the phone. But even if it's a little bit, it's a really cool thing. And I think this is like the future happening right here. Is we are moving more towards edge computing devices being more capable of executing ML stuff. So yeah, so that is TensorFlow mobile was there during our time, and we weren't able to do it back then. But now even Pytorch is coming out, and I think it's something that will really be helpful to a lot of people. And it's a really cool thing. Even if you are going for hackathons and all, if you're looking for building a mobile app that's focused around AI, you can explore this. It's not very simple as such. I mean, it has a learning curve. When I say simple, meaning that it requires some time of practice. It has a learning curve, but it's worth it, I think, if it's helping you build a good application. So that's about Pytorch for mobile. You can write a documentation on that, and I would definitely be reading it. Okay, like forget about winning the community challenge and participating in that. Like I would definitely want to know more about Pytorch for mobile. And then the thing is, their official website does talk about it, but then it's like, visit the GitHub repo, read a README, and things like that. If you have like one document that is really well drafted, like a nice blog, it will be a pleasure to read it. Like I'll genuinely enjoy reading it. Also, if you have any questions until now, you can drop them in the chat. Just a minute. Also, if I say something wrong somewhere, do correct me. Okay. So these are sort of the main documentation points that you can focus on if you're documenting Pytorch. Or if you don't want to do any of this, right? Say you've already installed Pytorch, you're like, hey, I don't want to write about the installation process again, or Pytorch mobile doesn't really interest me, nor does any of the ecosystems. I find that perhaps a little too much for me. I don't really use any ecosystem. So what you can do is then a quick recipe. So Pytorch codes are called recipes. You know, like you have notebooks, right? Jupyter notebooks. So they still refer to it as a notebook out here, but they have recipes. A recipe does stuff. A recipe is what it says, like the steps that you can follow to build something. So if you don't want to do anything, you can simply just document a quick recipe. So Pytorch is primarily used for NLP and image stuff. Okay, so text and video analysis is something that Pytorch can do really well of, which is also why deep learning, which is also one of the more popular applications for deep learning. Neural networks are capable of doing these things very well, image and video analysis. Because they do image analysis, they can also do video analysis. And Python also has NLP support too. So if you're going to be doing a quick recipe on this, right, say you build a simple image classifier. Let's pick an image classifier, okay? Or let's say, forget image classifier, we're talking too much about images. Let's pick a text classifier. You made a text classifier that tells you what kind of text a paragraph is, okay? If I give you a paragraph, it will tell me like, hey, this paragraph it talks about a person, or this paragraph describes a scenery, or this paragraph is a notice, or this paragraph is a news report, something like that, or this paragraph is talking about a celebrity, things like that. So if you're building a solution for that, um, you can write your code, you can have your recipe for it, and then you can document your recipe. Now when you're documenting, the very first thing that you should sort of focus on, your ML works on data. So talk about what data structures you are using for storage. Now Pytorch works on something called tensors. Okay. For those of you who are new to this, you have scalars, you have vectors, and you have matrices, and you have tensors. Okay. So typically, and you correct me if I'm wrong, but what I understand is scalar is a singular quantity. Okay. In the CS world, all right. A vector is a one-dimensional list, all right. You can call it an array. Then you have matrices, or a matrix is a singular form of it, which is a two-dimensional array. Anything that is three-dimensional or more is considered a tensor. Okay. But technically, like when you're reading blogs and all of that, nobody refers to two-dimensional, one-dimensional data as vectors or matrices. They simply call them one-dimensional tensor or two-dimensional tensor, and then tensor. So one-dimensional tensor, two-dimensional tensor, and then you have just tensors. So anything three-dimensional or more is called a tensor. So Pytorch works on tensors. Okay. Basically, like you have NumPy, you have the arrays and all of that. So it's based out of that. So you can talk about how you are using your data, how your data structures are holding this data. Okay. So that is the first step, which is data pre-processing, data collection, data pre-processing. Then you can talk about what is Pytorch offering you that is allowing your text analysis to become much easier. It's deep learning, so you're building a neural network. Okay. Now, if you're building a neural network, you can talk about what Pytorch is offering you that is making your work easier. A very good way to do this is to compare the performance of a neural network built using other libraries. I'm not sure if Scikit has, I think Scikit also has a neural network library. I think I used one. I'm not sure it was belonging to Scikit or it was belonging to someone else. But for example, if you build a neural network in Scikit for the same task, you build a neural network in Pytorch, you might notice that Pytorch is a little bit faster. Okay, which I think will be the case. You can document that, right? You can tell them that, hey, you know what, I did this. I got my data, I pre-processed it, I put it out there, and I wrote my code, and I see that, you know what, my classifier is working really fast as compared to what I did in like Scikit. So I feel like Pytorch is really doing something good out here. So you can write about that, like, you know, Pytorch is giving much faster performance, much better performance, much faster results. And if you feel like if you feel like comparing it to other popular frameworks out there, other popular libraries out there, you can do that too. So you can structure your recipe on this way, no matter what you pick. data structures that you're using, the process you're following, how efficient is the process, what is Pytorch offering you to make that process easier. You could say they have ready-made libraries for this, which is really cool. And then you can document that, performance-wise, Pytorch is really much, I feel like it's really cool. It's really performing better out here. It's not performing this well out here. So you can have these things in your document if you're going to be documenting Pytorch. See, yeah, that sort of covers documentation points that I had. In addition to this, there are more advanced things. For example, I talked about tensors, right? Now, most of the time, these data structures are not capable of being executed on GPUs. GPUs are your graphical processing units. They are usually executed on your CPUs. But the Pytorch tensor is capable of NVIDIA has something called as CUDA, okay, which is Compute Unified Development Architecture. It allows your GPU. It exposes the GPU's processing capabilities to a programmer. Okay, so Pytorch offers a CUDA interface where you can convert a Pytorch tensor into a CUDA data type, and then you can execute it on. So CUDA is NVIDIA's proprietary library, so proprietary framework. So it runs on NVIDIA graphics card. So you can convert your Pytorch tensor into a CUDA data type, and you can run it on a GPU. Now, if you run things on GPU, a GPU has lots of cores. Okay, it's a very powerful hardware device. So you will definitely notice a significant thing. But of course, this requires a bit of a. It will fall more into the advanced category because you need to have an idea about CUDA as such, about what kind of data types are available in NVIDIA CUDA, and then you also need to be comfortable with Pytorch to a certain extent, because you'll be basically changing the type of data, the data type. You need to know how it will be mapped, and but Pytorch does offer that capability of linking it to CUDA and running your code on an NVIDIA graphics card instead of a traditional CPU as a C. So that is one aspect that you can focus on. And similar way, you have like lots of other advanced things that I haven't really covered here, particularly because those things even I'm not very familiar with, because I haven't used Pytorch that extensively. I haven't used it that much, just know a bit about it. That's all. So I didn't feel like it was right to talk about all these advanced things. But if you are comfortable with that, then I think you can definitely go and pick that out too. But if you're just a beginner, or like maybe a little somewhere in the intermediate, beginner to intermediate skill, then you can focus on these points. You can let that be for now, because that is more into parallel processing capabilities, distributed processing capabilities. So that's it for the documentation points. I just wanted to sort of say what are the tips of a good document. The tips for a good document is number one is assume nothing. Okay, if you're talking about stuff, for example, let's say when we are talking about, for example, if you ask me, hey, how do I go about installing Python 3 on I don't know, on a Linux machine, on a Ubuntu machine, I'll say, you know what, use APT, and you'll be like, I don't know what APT is. Because we are so habituated to just using these simple terms, we might just might just speak it out without realizing that the person in front of us does not really speak that jargon, right? Similarly, if you're going to be addressing stuff out there, you might just say, I'll make a tensor and I'll execute this. And the person in your document does not know what tensor is. You use the word tensor without telling them what it is, or without even giving them a slight idea. The chances are they'll not read your document any further. Okay, or they might just drop it. They'll be like, this is too complex for me. Which is not the right thing to do. So assume nothing. If you're using some technical term or technical jargon, that in fact is a very simple thing. You can write a short note in brackets explaining what it is. Okay. Or you can have a link to the appendix of your document where you can explain what it is, or you can have links to other web pages that have comprehensive documentation explaining what that simple word means, right? It can be anything, but stuff like that. Okay. So don't assume anything when you're writing a document. Always, especially for a beginner level, don't assume anything. Explain everything. if you're talking about, like, I love these kind of documents, right, where they say, you know what, use apt to install it. They'll be like, hey, do you know what apt is? Do you know how it works? If you want to learn more about this, here's a link to a web page that covers this, or here's a link to a blog that covers this. So you can read it out here, and then if you want, you come back to a document and then continue with the other steps. So you can have a sort of a bit of a thing saying what apt is, and maybe stuff like that. Um, uh, Keep it structured. It's always good to have sections. Uh, there should be a beginning, there should be a continuation, and there should be an end, right? In a very broad way. These are three things. And so have sections, have an introduction, have a nice body, and try to segregate it as much as possible into smaller parts. Have images and commands for every complex steps. Okay, if you're doing something really complex, try to put in a screenshot. You can even have a GIF if you want. You can have a screenshot of the command, and you obviously have to explain what every flag in the command is. Assume nothing. The first point. So that will help you your document get a little richer. And in fact, the goal is to make it more readable to the end user. That is what it is. And if I'm a beginner, I don't want to get intimidated. Explain it to me like I know nothing, right? And one of the most important things, that is last but not the least, is citations. If you're picking things from repositories that don't belong to you, if you're picking code snippets, if you're picking any kind of stuff from the repositories that you have absolutely no ownership over, then please add citations. Please, okay? Don't just blindly copy stuff. Okay, like actually go through the effort of saying that I have taken this from this page, which can be found at this link. Okay, because someone has worked to do that. And if you're taking it, if it's open source, if you're taking it, it's a good thing. They want, but at least the least you can do is tell them that it's not yours. Don't pass it off as your property, right? So citations are also really important. And ethically, it's the right thing to do. So always have citations for anything. Chances are you might need a few citations in your thing, because you might take code from somewhere or some other repo or some other blog, some other tutorial. So always have citations. It's not wrong to take code from places that are offering you open source places. It's okay, but without citations, it becomes wrong. Okay, so add citations wherever you're adding stuff there. So that sort of is tips for a good document. I feel that sort of brings me to the end of my session. It was a particularly short one. I tried to cover everything. So yeah, I hope I was able to give you a nice idea about what we can go over doing it. So you have you can connect with me on these handles. Yes, Anita.
That was such a wonderful session, Abdul. I really loved it. So Abdul is the guy I go to if I need help with data science. He's the only person who makes data science interesting for me. So I thought there was no other better person to take up this session on Pytorch, and I knew he was going to do it so wonderfully. I love the pointers that you gave.
Thank you.
I love the stories that you actually told us, especially the one for hackathon. I can completely empathize. It has happened with me. Like, I've tried making an ML model once and we couldn't do it because we did not have a background for ML, and we were like, no, we are going to do all of this. And last में जाके image recognition भी नहीं हो पा रहा था.
It's a little intimidating.
Yeah, it is. It's very different than normal programming, right? Like, it takes time to understand how things are going.
Exactly.
So yes. So now I think I'm gonna stop recording, and then we can sort of get into a small discussion where we can share.
I see some questions. Maybe.
Yes, I see some amazing feedbacks for you here, Abdul.
Oh.
So let me stop recording, and this will go on the site.